With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello my dear student, here the given question is that using the Rolle's theorem, so that the derivative of the function, that is function f of x equals to x sin pi by x for x greater than 0 and 0 for x equals to 0, vanish at an infinite set of point on the interval 0, 1. At first, we explain the Rolle's theorem. So now I write this. Rolle's theorem states that f of x closed interval a comma b to r be a function such that number 1, f of x is continuous on the domain, that means closed interval a comma b, and number 2, f of x is differentiable on the interval open a comma b, such that f of a equals to f of b. Then Rolle's theorem states that then there exists a point C where the C point belongs to open a comma b, such that f dash c equals to 0. F dash c equals to 0. Here such that not here, and again I repeat, here Rolle's theorem states that if f of x is a function, the function is f of x is continuous on the closed interval, and f of x is differentiable on the open interval, and f of a equals to f of b. That means the value of the function at the end point are same. That means a and b are ending point. So then Rolle's theorem states that there exists a point C where the point belong a open interval a comma b, such that the derivative of the function at that point equals to 0. Okay, so we clearly understand that the Rolle's theorem. Here now come to the question. Here f of x we can write the function. Here the function is that f of x equals to x sin pi by x, where x greater than 0 and 0 x equals to 0. Now we investigate it. Clearly f of x is a continuous function, and we consider the interval 0, 1. So f of x is continuous on 0, 1. Why? Because in the question given that the interval 0, 1. So for this purpose we consider that interval. Sorry, this is closed interval 0, 1, closed interval 0, 1, and f of x is also differentiable. F of x is also differentiable on open 0, 1. If we differentiate the function, we can clearly understand that then that f of x is differentiable. If f of x equals to x sin pi by x or x greater than 0, so f dash x equals to x cos pi by x into minus pi by x square, okay, plus sin pi by x. Here x not equals to 0 because x greater than 0. So f dash x is defined clearly. If we write on simplification form, then we have sin pi by x minus pi by x into cos of pi by x. Okay, if we write clearly pi by x. Okay, so we clearly see that the f of x function is differentiable on the open interval 0, 1. And also if we calculate the value f of 0 means 0, because in the question that at x equals to 0 the value of the function is 0, so f of 0 equals to 0. Also f of 1, now we find the value of f of 1. f of 1 mean 1 into sine pi by x, because the nature of the function for x greater than 0 equals to x sine pi by x. Since 1 is greater than 0, so if we put 1, then we calculate easily the value of f of x. So f of 1 means 1 into pi by 1 mean pi. So sine pi equals to 0, so 1 into 0 mean 0. Therefore, we clearly see that f of 0 equals to f of 1. Okay. So here we see that all the conditions of the Rolle's theorem f of x must be satisfied. Again, if we consider the function sine pi by x, if we consider sine pi by x equals to 0, what are the point? The value of the sine pi by x equals to 0. Sine pi by x equals to 0. Pi by x equals to 0 means sine k pi. Okay, that's mean pi by x equals to k pi, or x equals to 1 by k, where k belongs to natural number, because here if we consider for k belongs to z, but it is not true, because here the domain of the function is x greater than 0, so the negative integer should be cancelled out. Therefore, for this purpose we consider k belongs to natural number. So here we see that at 1 by k, that means k belongs to natural number, the function sine pi by x is vanishes. So sine pi by x vanish. Where the point? So we write this: f of x is vanish at the point 1 by k, where k belongs to n. Okay, that's mean natural number, because f of x equals to x sine pi by x. Okay, so where the function sine pi by x is vanish, then f of x should be vanish that at that same point, because x into 0 means 0. So we see that here f of x is vanish at the point 1 by k, where k is the natural number. If we consider the interval, suppose we consider the interval, so now we write this. So f of x is so the Rolle's theorem applicable for the function f of x on the interval 0, 1, because all the condition of the Rolle's theorem satisfy for the function f of x. If we consider the interval, suppose half, 1 and 1 by 3, 2 and 1 by 4, 1 by 3 ... Similarly, if we consider 1 by k plus 1, okay, then for all that interval, f of x is vanish. Okay, and also Rolle's theorem also here we write this. Also we can say that f of x is applicable, Rolle's theorem is applicable. Also we say that Rolle's theorem is applicable on that type of interval. Okay, on 1 by k plus 1 by k, for all k belongs to natural number. Okay, clearly see that, because this interval belongs to the interval subset is here we say that 1 by k plus 1 comma 1 by k is a subset of 0 comma 1 because f of x is satisfies all Rolle's theorem condition on the interval 0 comma 1 and 1 by k plus 1 comma 1 by k is the subset of 0 comma 1. So Rolle's theorem is also applicable on that interval. Okay. So here you see that and also Rolle's theorem state that there exists a point C on that interval 1 by k plus 1 by 1 by k where f dash c equals to 0. So here we see that here there are many infinite points or there are many interval where the function is satisfy the Rolle condition. If we see the question vanish at infinite set of point on that interval. Set of point obviously because here this set if we count this is infinite set. This is infinite. Okay. So our answer is this. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.